Hello everyone, welcome to CSE Core Concepts in the series of computer networks. In this video, we are going to discuss about the Shannon's capacity for the noisy channel coding theorem. Now, earlier video we have discussed about something called as a noise. So, what have we discussed about noise? Is the unwanted signals are called as noise, undesired signals. So, we have discussed noise in terms of your thermal noise, which is due to the heating up of the devices, intermodulation noise. The same channel is being used, right? Crosstalk is very common with the twisted pairs and the impulse noise, that is the sudden burst of noise because of the thunderstorms or any other thing. So there are other important concepts which we need to know before studying the Shannon's theorem is the data rate and the bandwidth. So that we can compute the channel capacity. Now why we require to compute the channel capacity? Is the bandwidth not enough? No, because the channel is carrying some amount of data at a particular speed. That speed is called as a data rate. Okay, and a fixed amount of data is being transferred, that is called as a bandwidth, right? But due to the interference of the noise, the actual capacity of the channel may not be used. So we have to compute the channel capacity, that is the maximum rate at which data can be transmitted over a path. Now, noise is any unwanted signal because noise can interrupt, right? So, these are some of the important concepts you should know. That is the data rate, that is the rate, that is the speed in bits per second, and bandwidth is the amount of data that can be transferred. So, it is expressed in terms of cycles, or you can call it as the hertz. Now, Shannon's limit is the theoretical limit which will tell us what is the maximum capacity for a signal to be transmitted. So, it states that the maximum rate at which information is transmitted in the presence of noise. So, the formula is capacity is equals to B, that is the bandwidth, log to the base to 1 plus S by N. So, what is this stand for? Let us see. So, C is the channel capacity which we are going to compute. B is the bandwidth of the channel, that is amount of data transferring from the channel. S is the signal what you received, N is the noise, and S by N is the ratio of signal to noise, that how much is the actual signal, and in that signal how much amount is your noise, right? Now, this SNR is given in the linear form. This ratio is in the linear form, that is power of signal divided by power of noise. But this can always be expressed in the form of decibels by the formula, that is SNR in terms of decibels is equals to 10 into 10 to the base log to the base 10 S by N. Now, SNR can be represented in a linear form also, or in a decibel form also. So let us take an example that the signal to noise ratio is given 1000, that is in a linear form, and I want to compute the decibel form. So I can put it in this formula 1000. So what is 1000? 10 cube, that is log to the base 10. It will give you the answer 3 multiplied by 10, that is 30 decibels. Right. So the same SNR ratio given in linear form is 1000. Okay, linear form, and it is 30 in terms of decibels. So let us take some examples. A telephone line has a bandwidth between 300 hertz to 3300 hertz. Right. Now this range is given and we have to find out the exact bandwidth, and SNR is given in this form. This is which form? Linear form. Right. So the bandwidth first we compute, that is the upper limit minus the lower limit, that is 3000. Sometimes you will be given the direct value also, sometimes you will be given the range. And if you use the Shannon's formula, because since this is in the linear form, simply we have to replace. So bandwidth is equals to 3000 log to the base 2 1 plus SNR. So SNR is what? 3162. So plus 13163 to log to the base 2 will give you 11.62. If you multiply it with 3000, this is your bits per second, that is 34,860. Now, often students face this problem of computing log 2 because in your calculators log 10 and ln are given. So how will you compute the log 2 of it? That is, if you are using the natural log, you find out the natural log of that value, divide it by the natural log of 2. Or if you are using log to the base 10, you find out the log to the base 10 of that value divided by log 2. So that will give you the log of 2 value. Now, another problem, let us see that SNR is often given in terms of decibel. So let us, it is given 36 decibels, right? Not in linear form. And bandwidth is your 2 megahertz. So I want to calculate the theoretical channel capacity. So first I have to compute this, convert this decibel into the linear form using this formula. So here I will have to, now the problem here is that this is the linear form. This we know, this we have to compute, sorry, and this we know, that is 36. So I have to make this SNR as the subject of the formula, and I have to take this on this side of the equation. So I will get 10 to the power SNR in decibels divided by 10. So what is SNR in decibels? 36 divided by 10 will give you 3.6. Okay. So 10 to the power 3.6 will give you 3981 in the linear form. Alright. So this is 2 into 10 raised to the power 6, because bandwidth is what? 2 megahertz. 2 megahertz means 2 into 10 raised to the power 6. So 2 into 10 raised to the power 6 into log 3982 to the base 2. So if you compute this value, how will you compute this value using calculator? Log of 10 of 3982 divided by log to the base 10 of 2. You will get this value. So it is 24 into 2, 12 you may get. Okay, 12 into 2, 24, 24 megahertz. Understood? So this is how you can compute the Shannon's capacity, theoretical capacity. So sometimes you will be given in form of decibel, sometimes you will be given in the linear form, and using these formulas you have to convert. So don't forget to like, share and subscribe to this channel, and stay tuned for more such informative videos. Thank you.